Welcome back to the SWAYAM NPTEL course on mechanical and electrical systems of mining machines. So, we are in lecture 26, which is tutorial on bucket wheel excavator and dragline. It is a part of module 2, that is mechanical systems in heavy earth moving machineries. Now, in today's lecture, we will be covering tutorials on bucket wheel excavator and draglines. Well, as I have discussed while we were discussing for shovels, so I will be first discussing how do we find the capacity of a bucket wheel excavator. So, you have understood how a bucket wheel excavator works. So, what are the buckets and how they are arranged in series over the periphery of a wheel. Now, when we talk about the volume of a bucket, it is this volume of a single bucket, it is not the summation of all the buckets. So, how do we calculate the theoretical capacity of the bucket wheel excavator? So, it is given by this equation of QH is equal to I multiplied with S multiplied with 10 to the power minus 3 multiplied with 60. So, this is given in meter cube per hour. So, when we talk about the inner volume of a single bucket, as we have discussed in the theory class, it is specified in terms of liters. So, in order to convert it into meter, we divide it by 1000. So, here I is the inner volume of a single bucket in liters and S is the number of bucket discharged per minute. So, we converted it into cubic meter and then to hour we multiplied it with 60. So, because it is in minute, so we have to convert it into hour. So, we multiplied with 60. So, in shovel, when we are calculating the bucket capacity, it was in seconds. So, that is why we have converted into hour. So, we multiplied 3600 there. However, here we are converting the minutes to hour. So, we multiply it with 60. So, this gives us the measure of the loose material after it has been excavated by a bucket wheel excavator. Now, let us say for a solid or a bank measure, how do we do that? We add the component swell factor, that is SF. We divide this theoretical capacity of the loose measure with SF. So, we get it in cubic meter per hour for solid or bank measure. Now, here there are few more terms, that is the number of buckets in a wheel is defined by Z, and for the speed of the wheel which is given in RPM is defined by N. Now, the number of bucket discharged per minute is given by S. In the last equation here we have seen this S, which we can define it as N multiplied with Z. What is N here? N is the speed of the wheel and Z is the number of buckets in a wheel. So, that gives us the number of bucket discharged per minute, and the equation for a solid or bank measure, it is also applicable for loose measure, is modified as Q theoretical is equal to I multiplied with N multiplied with Z multiplied with 10 to the power minus 3 multiplied with 60 by SF gives us the theoretical capacity in cubic meter per hour. Now, we can also find the theoretical capacity by knowing how much is the slewing speed of this machine, which is given as meter per minute, which is given by Vs, and the cut height is given in meter, and the depth of cut is given in again meter. So, my theoretical capacity with the slewing speed and the height of cut and the depth of cut for a bank measure can be given as 60 multiplied with h, that is height of cut, multiplied with depth of cut, multiplied with the slewing speed, gives me the bank measure in cubic meter per hour. However, for loose measure, we multiply the SF here to get the theoretical capacity. Now, when we try to get the annual production, so how do we get it? Annual production is given by the service factor multiplied with the theoretical capacity multiplied with the hours that is run per year, gives us the annual production capacity in cubic meter per year. So, now one thing that you note, that while we are calculating from the bucket point of view, from the machine point of view, we are calculating the theoretical capacity of loose measure, because that is what the bucket holds. So, we do not know what is in the bank. Now, we divide the swell factor to get the theoretical capacity. However, when we are trying to get the theoretical capacity from the bank measure, or from when the rock is in undisturbed state, so there we directly get it from the cutting height, depth of cut and the slewing speed. So that gives us the bank measure, and then with that we multiply the swelling factor to get the theoretical capacity. So you should always take care of these terminologies and this kind of measurements while you are trying to determine the capacity of the bucket wheel excavator, because if you are measuring from bucket wheel point of view, so that the theoretical capacity, the calculation of theoretical capacity will be different. However, if you are calculating from bank point of view, the calculation of the theoretical capacity again will be different. Now, while we are talking about the annual production, we have a component here, that is the service factor. Now, this service factor is dependent on the working condition and the operational efficiency. So, generally as a thumb rule, it varies from 0.5 to 0.7. And when we calculate the swell factor, as I have explained, swell factor is always more than 1. So, it is 1 plus the percentage of swell. Now, let us try to solve one problem for bucket wheel excavator. So, what does it tell? These are the particulars that is referred to a bucket wheel excavator, where the bucket capacity is 500 liters and the number of buckets on the wheel is 10, and the RPM is given as 7, fill factor is given as 0.8, specified weight, that is bank measure, is given as 1.25 ton per cubic meter. So, you have to select a belt conveyor to match the bucket wheel excavator. So, what would be the capacity of the belt conveyor? So, now how do we know that? First of all, we should know what is the theoretical capacity of a single bucket for this bucket wheel excavator. So, how do we know that? The theoretical capacity is given as I multiplied with S multiplied with 10 to the power minus 3 multiplied with 60, that gives us meter cube per hour for the loose measure. And if I have to find the bank measure, what do I have to do? With this equation, I just have to divide SF, which gives me the bank measure, right? So, which is meter cube per hour. So, now if I have to find the theoretical capacity of the buckets with respect to the bank measure, so what do I do? My I here is 500 multiplied with S here is 7, S is equal to N multiplied with Z. So, my N is 7, my Z is 10 multiplied with 10 to the power minus 3 multiplied with 60 divided by 1.2. So, that gives me meter cube per hour is giving me something as 1400 meter cube per hour. So, here I have assumed my SF, my SF as 1.2. So, if I have to convert it into ton, so I multiply 1.25 ton per cubic meter will be giving me 1750 ton per hour. So, this is my answer. So, this is equal to 1750 meter cube per hour. Now, what is given here is this is my bank measure. Now, from this, let us say I have to fill the bucket, which is the loose measure. So, I could have not taken it 1.2, but then again I have to know the fill factor that is filled inside the bucket. So, with fill factor, my Q theoretical is equal to 1750 multiplied with 0.8, because this is the bank measure, and from this 0.8, that is 80% only my bucket gets filled. So, this is equal to 1400 meter cube per hour. And when I have to know that what should be my belt conveyor capacity, this is 1400 cubic meter per hour, and if we have to convert it into ton, so it is 1400 multiplied with 1.25, this is cubic meter per hour, this is ton per cubic meter. So, this gives me 1750 ton per hour. It all depends on what you have assumed your SF. Now, coming to the capacity of a drag line. So, now when we have to determine the capacity of a drag line, it is determined on hourly basis. So, how do we do that? The equation is similar to as of the shovel, where your Q is equal to the bucket capacity multiplied with the fill factor multiplied with the utilization factor divided by the swell factor. But here we have again another term which is multiplied with n. What is this n? That is the number of cycles per minute. Now, when we have the number of cycles per minute, in order to convert it into hours, we have to multiply the term 60 here in the numerator to convert the capacity on hourly basis, that is meter cube per hour. Now, as we have solved for shovel, so there is a technical factor which affects the capacity of a drag line, which you can see the formulae as 60 multiplied with the bucket capacity B multiplied with the fill factor F multiplied with the utilization factor U divided by the swell factor SF multiplied with the number of cycles N multiplied with KT, that is the technical factor. So, this gives us the capacity of the drag line when technical factor is taken into consideration on hourly basis, that is cubic meter per hour. Now, a question on this, we have to calculate the yearly extraction capacity of a drag line having bucket size. The bucket size is given as 15 cubic meter. So, this is B operates in coal mines having the following condition. The dragline operates 3 shifts per day. Working days per year is 350 days. Average utilization factor is 0.85. Average cycle time is 60 seconds, and the bucket fill factor is given as 65%. Now, when we find the solution to this problem, how do we find the capacity? We know that the hourly capacity of dragline is something like 60 multiplied with bucket capacity multiplied with F multiplied with U divided by SF, and here we multiply the N which gives us cubic meter per hour. Now here our B is 15, my F is 0.65, utilization factor is 0.85 divided by SF. SF again here we have to assume SF, let's say 1, then multiplied with N. So how do we find the factor N or the value N? N is the number of cycle per minute. So here average cycle time is given 60 seconds. So if we convert this 60 seconds into minutes, so this is 1. Here we have multiplied it to convert it into hour. So this gives us meter cube per hour. So again, now when we have to convert it into yearly capacity of dragline, so what do we do with this value? 15 into 0.65 into 0.85, this is 1, this is 1. So we multiply how many days? It is 350 days, and hours we have to convert it into number of how many hours? 3 shifts per day, and we convert it into per day. So per day it is multiplied with 24. So 3 into 8 gives us the number of days, the number of hours in a day, that is 3 shifts into 8 hours, and then we multiplied with the number of days. So this gives us the final value 4.177 into 10 to the power 6 meter cube per year. So this is the final answer. So this is how you calculate the bucket capacity of a dragline. So you can follow these references. Thank you.